Okay, so what I want to do here is just a quick whiteboard to reinforce some of the ideas we wrote about in the vROps operations stress analysis and right-sizing recommendations on vrelevant.net. So what I've done here is I've sort of set up a graph that is in line with the example I gave in the post. We see that we're looking at CPU demand. The usable capacity is 20 gigahertz. We have our stress threshold set at 70% by default, and 70% of 20 gigahertz is 14 gigahertz. So the 14 gigahertz line, once we cross that on demand, that's when we start tracking stress. And then I've got the tick marks going across the top where I'm chunking this into 60-minute segments. So we'll see 1, 2, 3, 4, 5, 6, 7, 8 hours represented here. We know that vROps operations takes data points every 5 minutes, so that gives us 12 data points per hour. And we know that the height of our stress window is 6 gigahertz because that's the 20 gigahertz usable capacity minus 14 gigahertz for where our stress threshold resides. So that gives us down here in the lower left a stress area of 72. Demand area comes in when we see CPU demand occurring. And if we look at a simulation of CPU demand, it might look something like this. And anytime that we cross that top line of stress threshold, we start creating areas that are tracked as stress. vROps operations is by default going to look for the past 30 days for the worst hour of stress. And if we look at what I've just charted out here, the first window we cross into appears by eye and ultimately does consume the most area of the stress area, right? So that demand is taking up more of the stress area than the other two windows. So that would be considered the worst. Now vROps operations is going to do the complicated math on these elliptical curves that are created from the 12 data points per hour. But if we want to look at this a little more easily in the example I gave in the post, let's just do something that looks a little artificial here. And we'll go straight across one of these. Okay, so this becomes our worst hour at this point. And let's pretend that this was right at 3. Okay, so we'll say our CPU demand was 3 gigahertz into the stress area. We know that the stress area is 6 times 12, 72. The demand area here, how much demand is in that window, is 3 times 12. So our demand would come out to 36. Our stress area is demand area, our stress score is demand area divided by stress area. 36 divided by 72 equals 50%. We operate in a whole number after that. So our stress score becomes 50. So simply put, that's how vROps Operations Manager is calculating a stress score. We do this for anything that has CPU demand, and we look for the worst 1 hour across the past 30 days, and we look beyond the stress threshold for stress. Anything below the stress threshold, your stress score is going to be 0. So the next topic we'll cover here then quickly on the whiteboard will be how do we use this data in analysis to determine right size recommendations. Okay, so here we have 3 different CPU demands being graphed. And if we look at them starting from top to bottom, the blue line is showing us a CPU demand cycle that is well into the stress area, but most importantly, it's in the stress area above a certain line. And that line by default, again set in the policy, is at 25%. When we're at 25% of our available stress, and I should have done this in green, I apologize. Anywhere in this window 25% across that stress threshold and below, we're considered healthy still. All right. The idea is that we do want to be stressed. We just don't want to be overstressed. If we're understressed, we're wasting money on capacity. If we're overstressed, we're suffering on performance. So this 25% over that stress threshold becomes our sweet spot and what we're aiming for. Now the blue CPU demand we can see is exceeding that 25% green mark. And it's probably at this point in the 4th hour going to be in the red range. It goes yellow, orange, red after that green. That blue CPU demand graph would be considered undersized. All right. If we look at the green cycle, we can see that this CPU is just touching in, and its stress score is going to be somewhere in the range of that 0 to 25% above that stress threshold, which equals a stress score of 1 to 25, somewhere in that window. Since this is what we're looking for, we consider this right-sized. The orange graph is getting nowhere near the stress threshold. This is what we consider oversized. So we have too many resources assigned to this orange CPU. Therefore, we're wasting resources. Okay, now, right sizing is a simple process then of determining how do we change this 20 gigahertz, which is our top line, which is driving our 14 gigahertz stress threshold line as a percentage, so that we compact it or expand it to take care of the oversized and undersized respectively. So with the blue, what we'd be looking to do is move our capacity usable up so that this worst hour is going to be falling within this range. Conversely, what we're going to do with the orange CPU is say that we want to shrink this number of usable capacity until the entire graph shrinks down and this 25% above threshold resides here. So with this one, we would probably see our usable capacity line closer to this mark, which based on the scale of this graph is probably somewhere around 10 to 12 gigahertz, right? So that's right sizing, and that's how vROI's operations manager is making its decisions for that based on the stress score.